Hey there, science fans. Today we're diving into the exciting world of organic chemistry. Specifically, we're going to explore two important reactions, E1 and E2 reactions. Now don't let the names scare you. They're just shorthand for elimination, unimolecular, and elimination bimolecular. These reactions are all about removing atoms from a molecule to form a double bond, kind of like creating a detour on a busy road. Think of it like this. You have a crowded molecule with lots of atoms bumping into each other. E1 and E2 reactions help create some space by forming a double bond, which is like adding an extra lane to the road. These reactions are essential for building complex molecules like those found in medicines and plastics. They're like the master builders of the chemical world. So, buckle up and get ready for a wild ride through the fascinating world of E1 and E2 reactions. Let's start with E1 reactions, which are like a leisurely stroll through the park. They happen in two distinct steps. First, a leaving group, kind of like a friend saying goodbye, departs from the molecule, leaving behind a positive charge. This positive charge creates what we call a carbocation, which is a bit like a lonely atom looking for a dance partner. In the second step, a base, like a friendly neighbor, comes along and removes a proton from a carbon atom next to the carbocation. This removal of the proton frees up electrons, which then rush in to form a double bond, creating a more stable molecule. And voila, we have an alkene. Now let's talk about E2 reactions. These reactions are more like a well-coordinated dance move, where everything happens at the same time. In an E2 reaction, a strong base swoops in and removes a proton from one carbon atom while simultaneously, a leaving group departs from an adjacent carbon atom. This simultaneous action is like a perfectly timed tango, leading to the formation of a double bond between the two carbon atoms. E2 reactions are usually favored when you have a strong base present and a molecule that's a bit hesitant to form a carbocation. So, how do you know which reaction will occur, E1 or E2? Well, it's all about the reaction conditions. E1 reactions prefer tertiary substrates, weaker bases, and protic solvents. They like to take their time. On the other hand, E2 reactions favor primary substrates, strong bases, and aprotic solvents. They like to get things done quickly. Think of it like choosing between a relaxing train ride, E1, and a fast-paced car race, E2. Both will get you to your destination, a double bond. But the path you choose depends on your preferences and the conditions of the journey. And there you have it, the amazing world of E1 and E2 reactions. These reactions are essential for understanding how organic molecules transform and react. So keep exploring, keep experimenting, and remember, science rules.